Imagine a vast expanse of water, seemingly serene yet devoid of life. The surface may look calm and inviting, but beneath it lies a stark and haunting reality. This is the stark reality of ocean dead zones, underwater deserts, where the lifeblood of the sea, oxygen, is tragically scarce. These areas are devoid of the vibrant marine life that once thrived here, leaving behind a barren and desolate underwater landscape. These underwater graveyards, scattered across our planet, stand as a chilling testament to the impact of human activities on the ocean's delicate balance. Pollution, overfishing and climate change have all contributed to the creation and expansion of these dead zones, turning once thriving ecosystems into lifeless wastelands. The silence of these dead zones is a deafening alarm bell. It is a stark reminder of the damage we are inflicting on our planet and the urgent need to take action. The absence of sound, the lack of movement, and the eerie stillness all serve as a powerful warning of what could become of our oceans if we do not change our ways. It's a stark reminder of the interconnectedness of all life on Earth and the urgent need to address the growing threat to our oceans. Healthy oceans are teeming with life, from the smallest plankton to the largest whales, all playing a crucial role in maintaining the balance of marine ecosystems. The contrast between these vibrant ecosystems and the desolate dead zones is a powerful illustration of what is at stake. Join me as we dive into the depths of this critical issue, exploring the causes, consequences, and potential solutions to these silent killers of the sea. We will investigate the human activities that have led to the creation of dead zones, the impact they have on marine life and coastal communities, and the innovative solutions being developed to restore the health of our oceans. Together, we can make a difference and ensure that our oceans remain vibrant and full of life for generations to come. Ocean dead zones, also known as hypoxic zones, are areas in the ocean where the oxygen levels are so low that marine life struggles to survive. These zones are characterized by a significant depletion of oxygen, making it extremely difficult for most marine organisms to live and thrive. The lack of oxygen in these areas can lead to massive die-offs of fish and other marine creatures, disrupting the entire ecosystem. These are not areas entirely devoid of life, but they are areas where only certain specially adapted creatures can endure. Species such as some types of worms, bacteria, and certain fish have evolved to survive in these low-oxygen environments. However, the biodiversity in these zones is significantly reduced compared to healthier ocean regions. These harsh conditions are a direct result of excessive nutrient pollution, primarily caused by human activities. Nutrients like nitrogen and phosphorus, often from agricultural runoff, sewage, and industrial waste, enter the ocean and fuel the overgrowth of algae. When these algae die and decompose, the process consumes large amounts of oxygen, leading to hypoxic conditions. These dead zones can be found in coastal areas around the world, particularly near heavily populated regions with high levels of industrial and agricultural activity. Urban runoff, wastewater discharge, and the use of fertilizers in farming all contribute to the nutrient load in these waters, exacerbating the problem. The impact is not just limited to marine life, it also affects local fisheries and the communities that depend on them. The Baltic Sea, the Gulf of Mexico, and the Chesapeake Bay are just a few examples of regions grappling with the devastating effects of these underwater deserts. In the Gulf of Mexico, for instance, the dead zone can expand to over 6,000 square miles during the summer months, severely impacting the local fishing industry. Efforts to mitigate these dead zones include reducing nutrient runoff through better agricultural practices, improving wastewater treatment, and restoring wetlands that can naturally filter out pollutants before they reach the ocean. One of the primary culprits behind the formation of ocean dead zones is a process called eutrophication. This occurs when an excess of nutrients, primarily nitrogen and phosphorus, from agricultural runoff, sewage and industrial waste enters coastal waters. These nutrients act like fertilizer for algae, causing them to bloom excessively. As these algal blooms die and decompose, bacteria consume vast amounts of oxygen in the water. This process depletes the oxygen levels in the water, creating hypoxic conditions that are deadly for most marine life. The impact of climate change further exacerbates the problem of ocean dead zones. Warmer water temperatures, a direct consequence of climate change, hold less dissolved oxygen, making these areas even more inhospitable for marine life. Furthermore, climate change can alter ocean currents and wind patterns, disrupting the natural mixing of water and further contributing to the formation and persistence of dead zones. This deadly combination of factors paints a grim picture for the future of our oceans if we fail to act. Section 5. A Silent Apocalypse. The Impact on Marine Life. The consequences of ocean dead zones are catastrophic for marine ecosystems. Fish, crabs and other marine creatures depend on oxygen to survive. When oxygen levels plummet, these creatures suffocate and die, leading to mass die-offs and a significant decline in biodiversity. The loss of these creatures disrupts the delicate balance of the food chain, impacting predator-prey relationships and ultimately threatening the livelihoods of coastal communities that rely on fishing and tourism. Section 6. Adapting to a breathless world. While many marine creatures struggle to survive in low oxygen conditions, some species have developed remarkable adaptations to endure these harsh environments. Some fish, for instance, have evolved to tolerate lower oxygen levels, while others have altered their behavior, moving to shallower waters where oxygen is more abundant. However, these adaptations come at a cost. Living in a constant state of oxygen deprivation can lead to stunted growth, reduced reproductive success, and increased susceptibility to diseases. Section 7. The Gulf of Mexico. Dead Zone, a case study. The Gulf of Mexico is home to one of the largest and most studied dead zones in the world. This area, devoid of oxygen, is inhospitable to most marine life, creating a barren underwater landscape. Fueled by nutrient runoff from the Mississippi River, this massive dead zone forms every summer, stretching for thousands of square miles. The nutrients, primarily nitrogen and phosphorus, come from agricultural fertilizers, animal manure, and sewage. When these nutrients reach the Gulf, they trigger massive algal blooms. As the algae die and decompose, they consume the oxygen in the water, creating hypoxic conditions. This lack of oxygen forces marine life to either flee or perish. Fish, shrimp and other species that cannot escape the area suffer greatly, leading to significant economic and ecological consequences. The Gulf of Mexico dead zone is a stark reminder of the interconnectedness of our actions on land and the health of our oceans. It highlights the urgent need for sustainable agricultural practices, responsible waste management, and a concerted effort to reduce nutrient pollution. By adopting practices such as cover cropping, buffer strips and precision farming, we can significantly reduce the runoff entering our waterways. Additionally, improving wastewater treatment and reducing industrial discharges are crucial steps in mitigating this environmental crisis. The health of our oceans depends on the choices we make today. Section 8. Turning the tide, combating ocean dead zones. The fight against ocean dead zones requires a multi-pronged approach, targeting the root causes of this environmental crisis. Reducing nutrient runoff from agricultural fields through sustainable farming practices, such as reducing fertilizer use and planting cover crops, is crucial. Upgrading wastewater treatment plants to remove more nutrients from sewage and reducing industrial discharge are also essential steps in mitigating this growing threat. Section 9. Collective Action for Ocean Health. Addressing the complex issue of ocean dead zones requires a global effort. International cooperation is essential to share knowledge, implement effective policies, and monitor the progress of our actions. By working together, we can reduce nutrient pollution, combat climate change, and restore the health of our oceans for future generations. Section 10. A future without dead zones. The future of our oceans hangs in the balance. The continued expansion of ocean dead zones poses a grave threat to marine ecosystems and the livelihoods of millions of people who depend on them. However, there is still hope. By understanding the causes and consequences of dead zones and by embracing sustainable practices, we can reverse this alarming trend and create a future where our oceans are teeming with life once more. The time to act is now.